All right, in this section, we're going to look at techniques in demonstrating how to add numbers. So I want to start off by mentioning the intention behind this section. I am not teaching this section because I'm nervous that you don't know how to add. That's not the point. When you get to an elementary school classroom, you're going to have lots of different learning styles, and you're going to have lots of different techniques in how to illustrate a concept. It is not sufficient enough, unfortunately, to simply throw a kid some numbers and go add them. You need to show them different ways to visualize and think about how adding works. And so the intention of this section is to look at different techniques in how to teach adding. Okay? Future sections, we're going to look at other skills. So if you go into it like this, that you're learning about the technique and not the skill, I'm not doubting that you know how to add. I want you to understand different processes that you can illustrate addition rules. Okay. So the first technique we're going to look at is called counting on. And counting on is an example. I'm going to throw out two numbers here. So 5 plus 3. The idea behind counting on is we start with a number and we count until we get to the end of the other number. So we count from one number to another. And it helps if you're a little organized. So you want to start with the larger number. And then the smaller number you just count on top of that. So in other words, if I start at 5 and I count 3 units, then I go 6, 7, 8, and so I end up at 8. And so 5 plus 3 is 8. Okay, that is referred to as counting on. Okay, in the set model, we're going to look at the union of two disjoint sets. Okay, now in other words, that means we're going to draw pictures representing the numbers and combine them together and look at the total. So if she's got, suppose Jane's got 4 blocks in one pile and 3 in another. Okay, so that means we've got two sets. In set A, we have 4 blocks, and in set B, we have 3 blocks. Okay, and I want to combine those together. Well, now again, you and I would look at this and go, well, that's got to be 7, right? But for some kids, they need to visually see that when you combine these sets. And we can go one step further because we're looking at the union of two disjoint sets. So if I look at, say, the cardinality of set A plus the cardinality of set B, that would be 4, that would be 3. I get the cardinality of the union of these two sets, which is 7. All right, so that brings up a very technical definition of what it means when we're actually adding whole numbers. And so we can look at it like as we add the two different whole numbers, we're adding two disjoint finite sets. And because they're disjoint and finite, then we can apply that cardinality principle that we just looked at in the previous example. Okay, another method of addition is what's called the number line model, and that's where we literally use a number line to model various problems and help the students to visualize the impact on the number line based on various situations that are brought up. So both of these sentences, by the way, involve the same operations, but we're going to use the same number line to illustrate that. So in the first one, Josh has 4 feet of red ribbon and 3 feet of white. How many feet of ribbon does he have altogether? One day, Gail drank 4 ounces of juice in the morning and 3 at lunch. If she drank no other juice, how many ounces did she drink the entire day? So both of them, we can set up a number line. 0, 1, 2, 3, 4, 5, 6, 7, I'll go up to 9. Okay. And we can say that in either way, we start off at 0 and we end up at 4. And then we add an additional 3 on top of that. So what number is the same as those two together, and that's where we get 7. So in other words, 4 plus 3 equals 7. But we use the number line to visualize how to combine those numbers. Okay, a couple of definitions and properties we're going to look at. The first one is this idea of less than. And again, I know that, or at least I'm assuming that as students we understand what the idea of less than is, but again, it's different ways to visualize this that we need to help students understand. Now, what we mathematically define as less than means that for any two numbers, we say that A is less than B, we write it in that symbol, means, and especially the idea of that if it's less than, means that if I take A, I can add something to it. I don't really know what that something is, but there exists something that I can add to it to get to B. Okay, that literally is what A less than B means. We can add a little bit more to it, so if I say A less than or equal to B, that means that either A is less than B, in which case we already have that definition taken care of, or A is equal to B. And then one step further, if we say A is less than B, that's also equivalent, and I can't stress this enough that this is something we need to emphasize to kids, that if A is greater than B, sorry, I said that wrong, A is greater than B, that means B is less than A. That we need to be able to invert and reverse our thinking on both sides in order to get a stronger understanding of what the math is actually trying to say. Okay, so let's just look at a few properties here. The closure property of addition of whole numbers. Closure is sort of interesting. It says that if I take any two numbers that exist in some sort of criteria, that I can add them and I get another number that also exists in that same criteria. So the closure property is that if A and B are elements of the whole numbers, then A plus B is also an element of the whole numbers. I don't have to necessarily worry what that is. I just know that if I take any two elements in a set, I add them together, I'm guaranteed to have another element in that set. Okay, the commutative property of addition of whole numbers is A plus B is the same as B plus A. Going back to that number line idea. 1, 2, 3, 4, 5, 6. If I take 2 and I add 4, or if I take 4 and I add 2, I still get 6. Any way around, you're still going to get 6. Okay, the associative property of addition says if I'm adding a series of numbers, so if let's first start off with the conditions that A, B, and C are all whole numbers themselves, all part of that set, then if I am adding together two numbers, if you add together three numbers, you have to add together two of them to start off with. And the order in which you add doesn't matter. So whether I add the first two and then throw the third one in at the end, or I add the last two and throw the first one in, I'm going to get the same sum. The identity property of addition of whole numbers. Identity property says that there is some number that I can add it to something and I don't change the value of it. So you got to think for a second. What number can we add to anything and not change the value of it, and that would be 0. Okay, so there's a number 0 such that if I take any element of the set and add the 0 to it, I don't change the value of it. Okay, so 0 we also refer to as the additive identity. Let's do a little bit of practice on these properties and identifying which one we're staring at. So let's start with something like 5 plus 7 equals 7 plus 5. Which of the properties did we just talk about that we're looking at? This is in fact the commutative property. Sorry, of addition. There are other commutative properties out there, so we want to specify that we are dealing with addition. Statement B, if I take 1001 and add it to 733, I'm going to get a unique whole number. That's an illustration of the closure property of addition. Okay, down below, C, 3 plus 5 plus 7 is the same as 5 plus 3 plus 7. Okay, so you want to emphasize to your students, notice what changed. Did the parentheses move or did the order of the numbers move? And if you think about it, the only thing that actually switched was 3 and 5. And the property that allows me to switch the place of two numbers would be the commutative property. So commutative property of addition. All right, this fourth statement, 8 plus 5 plus 2 is equal to 2 plus 8 plus 5, which is equal to 2 plus 8 plus 5. Okay, so we have a couple of different rules going on here. Let's just focus on that right there. What physically happened there? Did we switch where the parentheses are connected, or did we just switch the order around of some values? And we didn't move parentheses. So at this moment, we haven't used the associative property yet. That part right there is still the commutative property. Okay. However, let's look at this statement here. Okay, what happened there? In that case, the parentheses jumped from 8 and 5 to 2 and 8. And the property that allows us to do that is the associative property. These are all of addition.